and welcome to this Domopalooza presentation. My name is Sam Vishrelli, and I am a program manager with the Facilities, Infrastructure, and Safety Department at Stanford Health Care. I'm joined by Samvedna Sinha, the lead business systems analyst for technology and digital solutions, also at Stanford. To quickly explain what is meant by facilities, my department, it's basically anything that's hidden away in the hospital, in maintenance rooms, or within the walls. So that's HVAC, water, electrical, and specifically, I oversee a couple of our major assets, such as the 70+ elevators we have on property, or the subject of today's presentation, the pneumatic tube system. And today we will be talking about how we use Domo in active daily management to improve operational efficiency. So there are a couple buzzwords in there, but I do think they have actual meaning and value behind them. So what do we mean by active daily management? It is a lean practice, although I don't claim any expertise in lean. But basically, we have goals and certain performance indicators that we want to achieve. And on a daily basis, we look at whether we're on track or off track to meet those goals. So I think of daily management as doing those type of system wellness checks. How did the system do yesterday? How does last month compare to this month? And if we're off track from where we want to be, what types of corrective actions do we want to take? Related to this, written on one of the walls in our office is this statement, guiding principle to make problems unavoidable by making them visible. And one tool we have in making problems visible is the Domo dashboard. It's my personal and professional philosophy that problems are inevitable, but they are also solvable. And the solutions we implement translates into operational efficiency. So a roadmap of the next 30 minutes or so. I'll start by going over the program part of daily management, and Samvedna will talk about the history and creation of the dashboard, followed by a tour of the dashboard itself, and finally we'll go over several use cases that we've seen so far. So if you're like me, hearing the words pneumatic tube system might conjure up an image like this, something old-timey, black and white, the technology of yesteryear. Here's a more modern example of a pneumatic tube you might be familiar with, although I think it's also largely out of use. I can't remember the last time I was physically at a bank, but I am old enough to remember drive-through banking where you would deposit your check or get cash receipts or whatever else, and they would send it via a pneumatic tube. And when I was a child, it would also contain a lollipop, as I recall. The pneumatic tube at Stanford, what we affectionately call the P-tube, is a bit more complex. It has software, electrical, mechanical, and hardware components all working together in a synchronized fashion. A variety of items are sent through its tubing, including blood samples and other specimens such as medicine from the pharmacy, paperwork, even a pair of socks if a patient's feet are cold. Most items are faster if they're sent via the P-tube than walking it, for example. You can see some of our transactional data there, some of the data we look at using Domo. Is 9,500 transactions a day a lot? Well, everything's relative, but here is some context. My boss happened to be at another hospital a month or so ago, and they had a pneumatic tube system, and he asked about their volume, and they reported they did 200 to 300 transactions per day. We do more than that each hour of every day, so it is a big system. A bit more about how it works. Let's say you go to the doctor to have your blood drawn. The blood goes from your arm into a vial. The vial goes into a bag, which goes into a carrier, and then into one of these stations where it will be sent probably to the lab for analysis. And the time it takes to go from the sending to receiving station will vary, but it's usually within 5 to 10 minutes. And that time frame is critical for some samples because they're time sensitive. They will expire due to temperature or air exposure. So that's one metric in Domo we need to be aware of. How long are critical samples taking to arrive at their intended destination? As part of active daily management, we have a structured program comprised of a broader team with defined roles and skill sets. And within that group, you can see some of the uses we have for Domo in the program. All of these are an important part of my job, and Domo makes these reports and presentations much easier to create because the data is readily available and it's easy to get out of it what you want. One key partner in the P2 program is our IT team. They're the ones that took this machine process and turned it into accessible data, and they were critical in designing and implementing the Domo dashboard. So for that part of the story, I'll turn it over to Sambedda.
Thank you, Sam. So yeah, our story started with the problem statement for PTube, which was a lot of manual dependency to generate the data. PTube, even though it has existed in Stanford's history for more than decades, it was only recent that we started looking at this platform from not just a complex mechanical equipment standpoint, but also a very sophisticated software platform, and it has a ton of stories to tell. The problem was that we didn't have access to the continued story. The system is sensitive enough just to store 45 days worth of data. And as our footprint was growing in Stanford, as we were expanding our pneumatic tube system operations, that was not enough. We wanted to compare our data. We wanted to see how did we do, months before, and compare it to current to understand how our operations are, how can we scale it, and we just didn't have any way to just compare the data. So our objective was to find a platform where we can display the KPIs, the key performance indicators of P2 platform, and also a system that is, easy enough for people to just understand the data, and facilities being a department with all and many different types of skill sets involved. We wanted to make sure that it is an easy platform for people to understand and doesn't require a ton of training. We also wanted to use this platform to be able to communicate to our end users what's happening with PTube. What are some of our planned activities, what are some of our unplanned activities, how unplanned activities have impacted the system, and things like that. What you see on the screen right now is a heat map, which we used to produce in spreadsheets back in the day when we were launching or when the new Stanford Hospital, the state-of-the-art facility, was opening at 500 Pasture Drive. We wanted to see how our PTube system is performing in order to understand how do we scale up operations. And we had to produce this data multiple times a day to basically understand how to make some of those operational decisions. So some of our problem statements come from that time, and our vision was to really see an integrated platform for facilities so that a lot of the diagnostics and analytics for various facility systems can come together and be stitched together in a single platform to tell the story of facilities within Stanford. Pneumatic tube system being the most complex use cases of ours was the first problem that we set out to solve. If you go to the next slide, please. The dashboard itself was easy to create in terms of, from a technology standpoint. It was not difficult for us to present our story because we knew what we wanted to present. We connected our data with multiple data sources, not just P2, but we also connected to our enterprise asset management system. And we started visualizing the data. That's when, during the implementation, we realized that there are multiple use cases that we can solve here. So the enterprise asset management system, which holds the data of all of our assets, including pneumatic tube systems, has a functionality of preventive maintenance. What Domo helped us realize is that when we merge the pneumatic tube system data and enterprise asset management data, what it can help us transform is moving from a time-based preventive maintenance program to a usage-based preventive maintenance program. The pneumatic tube system gives us daily transaction counts of every asset, so we can see how each asset is being utilized throughout the day, and we can keep a count of it in our enterprise asset management system until it reaches a particular threshold, and then we can automatically create a work order to go and perform the maintenance instead of just doing it on a monthly basis or weekly basis. Now we are really maintaining the assets depending on how they are being utilized in the system. It's a very powerful use case that we could resolve, or we could, or the system helped us visualize when we started putting the data together. Um, we see it as a digital transformation, that we could do, and this would also help us achieve our sustainability goals. If you could move to the next slide, please. The data visualization story of ours is basically moving from a complete 100% manual mode to a completely automatic mode right now. Back in the day, downloading the data from PTube system was a manual process, of course, but generating analytics out of it, every step of that process was manual. The data out of pneumatic tube system was not readily consumable, so we had to convert it into CSV files. We had to put data in MS Access databases. We ran queries. We refreshed spreadsheets on a daily basis, and then we emailed out report. As you can see, every step of the process was a person-dependent work. We were uploading data in Box. We tried uploading data in SQL. None of these processes were sustainable enough or scalable enough for us to rely on. We had multiple challenges, as you can see, with, as is very obvious with a person-dependent process. When we got Domo, we knew that it was, we could connect to multiple data sources. So currently at this point in time, we are connecting to Pneumatic Tube System and Enterprise Asset Management. We are visualizing those data on a daily basis in Domo. There is absolutely no manual intervention. We are merging the data together behind the scenes, and then we are writing a file back to our enterprise asset management system on a daily basis, so that we can do the preventive maintenance based on the usage. Everything happens automatically before 9 a.m. every morning. All of these processes and data sets are refreshed, run, and we are ready to go. So this is a really great success story where we had, there was a time where multiple people from our teams were assigned to generate the analytics on a schedule, so that leadership can have a view of the data. But right now, every day, 4 o'clock in the morning, all the analytics are refreshed automatically. And by 9 a.m., we are sending what has happened previously, the previous day, to enterprise asset management system. If you move to the next slide, you will see that our data flow overview. So the type of components that we have utilized in Domo, of course, as I said, pneumatic tube system is a very complex system, and the way it is implemented in Stanford is the first in the world. We didn't have any reference, so we have been very creative in downloading the data from PTube using Automation Anywhere software. There are VB scripts running to convert that data into CSV format. Fortunately, all these processes are automatic as well. And then it becomes consumable. It reaches a point where Domo Workbench can consume it, refresh our data set, our ETLs can fire, and our analytics can be visualized. We are using CSV connectors to connect data from the enterprise asset management system. We are using write back connector to write data back to enterprise asset management system. We are also using publish functionality. So as a Stanford, within the Stanford umbrella, we have multiple entities. We are Stanford Health Care. We have a Stanford Children's Hospital as well. And as you saw in the previous slide, pneumatic tube system is a vast system that across both entities. So it is 15 miles long. It runs across both the facilities. So we had to make this data visible to both the hospitals. However, both the hospitals are separate have separate identity providers. So we used publish functionality to create a subscription instance and publish the data to them. We started it to make sure that we can publish the data to Stanford Children's Hospital, but there is so much to explore there for us to make sure we can slice and dice data and present it to them, as they need in the future. Um, so yeah, as all of these use cases we could resolve, you will hear from Sam more on how it is helping operations make better decisions. Over to you, Sam.
All right, thank you, Sam Bedna. And now for a tour of our dashboard. This is what it looks like. The design for me is a crucial element, especially because it's a friendly one. It uses the standard Stanford brand and colors and has a nice background image there, the pneumatic tube looking like a large musical organ, the type the Phantom of the Opera might play. To make another point about the design, there is a plain language initiative at Stanford, meaning to use simple language in our communication instead of language that's dense or jargon laden, more one point lessons that fit on a single page rather than overly detailed procedures. And to me, the Domo dashboard is plain language. It's easy to read and understand thanks to these cards and graphs that anyone can use. And if you want the details, they're still there accessible under this friendly frame. So I'll highlight a few of the dashboard's features. It's useful in communicating planned downtime so that end users can be aware of when the system won't be available. It has handy links for some of the routine meetings we hold, and it's a fun place to celebrate some of the milestones we've had, like reaching 10,000 daily transactions, which we did last December. Here's one set of metrics we use in our daily huddle, looking at the latest volume and percent of delayed carriers and how many consecutive hours we were above 450 transactions per hour. Basically, that's a look at how much we are physically testing the limits of the system. The daily volume isn't something we necessarily want to grow higher and higher as a measure of success. It's more of how are people using it? Can we physically keep up? What changes do we need to make to accommodate any growing traffic within the system? The percent of delayed carriers we do look at because that is measuring how many deliveries were outside of that transaction time window we expect. So if that percentage is really high, we do want to look at that, see what the cause was, and come up with a way to mitigate that. The next part here is one of my favorites where you can easily see an hour by hour breakdown of transactions for the entire day and also the breakdown of transit times. It's fortuitous we're recording today because Domo does highlight that there was a possible issue with the system yesterday. As you can see, between 8 and 10 a.m., there were transactions taking longer than 20 minutes that increased in number. Typically, we only see a few per hour, not a few dozen. So that's something the broader PTube team is looking at today as I speak, and it was just something that we noticed as part of our daily huddle. This view I can further filter if I want to look at a particular route, for example, what was sent from the children's main pharmacy, and just with just one click, I can filter. So again, this is taking what was lengthy spreadsheets, thousands of rows of data, and presenting it into an attractive and easy to use dashboard. And if you want to drill down into the data, that's something you can do, which I'll illustrate in one of our use cases. So moving back to the presentation, before we get into the use cases, I did want to speak about the rollout of the dashboard and my interactions with Sam Vedna's team as we look to continuously improve the dashboard. I think everybody who's enrolled a new process or piece of software has met resistance or people wondering why is there this change, why is there this new thing. So something we did with the rollout of Domo was to stay ahead of that and share frequent updates with end users, letting them know progress as we're building Domo out, periodic reminders that, hey, this new thing's coming, here's how it'll be relevant to you. And then once the dashboard was ready, we did hold training sessions so people could see how to use it, how it would be useful, just to get them acclimated. And I still call it out whenever I present, just to keep that awareness fresh and so leadership can see the value we get out of it. Sam Vedna and I meet every few weeks to discuss any issues, requests, or comments that have come up, either for myself or other users, and work to find answers or solutions. So as the last part of our presentation, talking about some of the use cases, we have a lot of P-tube related construction projects coming up, and some have been in the design phase for 12 months, 18 months, and work was done at the time to determine how much traffic was coming from those locations, and how much we anticipate there will be when the construction is complete months or years down the road. Um, so we make sure we're designing to the projected volume. Now that some of those construction projects are imminent, we want to double check the projected numbers against real values to make sure the designs match our current volume. And again, there were limitations with how it was done previously, but now in Domo, we can easily compare past and present volumes, just see how they match and validate with those numbers with a few clicks, which I'll demonstrate now. Going back to this view, um, there are several stations in our hospital, 500 Pasteur, that are going to be sending to the lab. So what I'm doing here is just clicking the ones that I know are going to end up going to that lab. So they become the source stations, and then the destination station is the lab. And there, with a few clicks, I've been able to look at the routes I want, and I can further go into details on this page. Um, change the time I'm looking at, so not only from yesterday, but the previous week, the previous month. And if I want the data, it is also just one click away there as an exportable spreadsheet. One of my favorite use cases was one day I got a call from our nurse manager. So she had seen Domo, she got access herself, got training, and it got her thinking, I know our area is busy, but how busy is it? Is it busy all day? Are there spikes during certain times of the day? Those are the kind of things she was wondering about. So we jumped over into Domo, and at first if we can jump back into the dashboard, clear the filter. At first I just filtered, she happened to be in the lab, so I filtered those views for her and jumped into the same one I just showed you here. So this gave her some idea of what transactions were coming to all the stations within the clinical lab. And again, we could filter it any which way we wanted. I think we ended up actually looking at the previous year. I ran that report for it, and it was over 200,000 lines in a spreadsheet. And you can look at it by week, by month, whichever way you want. In addition to that, she had a request to look at a single station. There was one station in the area that was known to be busier than others. Is there a way we could narrow it down? The answer was yes. If we move over to the analyzer feature, one part I like about this is you can add the data label, so it makes it easier to know how much is coming in at a given time. Easy to switch over to the data here and then further narrow it down to the actual destination, which I knew was station 222 in the clinical lab, which then populated there. And again, I could just adjust the times that she wanted to look at. So within 20 minutes, she had all the data she needed to be knowledgeable enough to revisit her staffing levels. And from what she told me, it did look like she needed more people during certain hours of the day because the volume was that much higher, and would need to rotate her staff more quickly during those peak times because, as it shows here, the carriers aren't exactly light, and handling them with that kind of frequency can be a physical strain. This screenshot is taken directly from the dashboard, and I like it because it just makes it immediately obvious that at any time of day we have 40% to 50% of the carriers in the system that don't have anything in them. They are empty. Now that's necessary because empty carriers are needed to be redistributed so that they can again be filled and used. But it is also strange to think at any given time there are carriers moving around with nothing in them. It would be a bit like being in a traffic jam on a freeway and looking around and noticing there are no drivers in the other cars. I think you would rightfully ask, well, where are they going? Why are they clogging up lanes of traffic? This is one we don't have a great solution to. We have a few mitigation steps that we take. What we do with some of the heavy use areas, which again we can identify through traffic patterns in Domo, is limit their traffic at certain peak times. Again, to use a traffic analogy, it's a little bit like the red lights on on-ramps to regulate how many cars can go through at a given time. Although the process we use now is more like turning off the entire on-ramp for an hour in a day, just to totally cut off the traffic. So it's not a perfect solution because I know our users expect to be able to use their station just as a driver would expect to be able to access an on-ramp at any time of the day. So still in process of finding a better solution, but again, this is just the sort of thing that the data available in Domo made obvious. Automating metrics. So each month I create a metrics report that I send out to various groups. I've never really timed how long it takes me, but it is a chunk of my day to create the report because it's a manual process and it does require a lot of cleanup. We look at things like mean time to repair and mean time between failure. Um, but because Domo is linked to our asset management software, we can automate the process. So everyone was excited about that possibility. But we discovered when we turned it on and ran the report that there was a discrepancy between my numbers and the numbers we saw in Domo. Now, why was that? And it is because I'm doing a fair amount of data manipulation. That's because sometimes the data is missing or incomplete or irrelevant. I don't want to include it in my calculations because I'm only looking at what was an actual asset failure. This is an item I've worked with Sam Vedna on. What logic can we apply in Domo to do the same filtering or cleanup that I do? And we've made some inroads there. And there is a discussion too to let's get the data as good as we can, then let it just speak for itself, even if it's imperfect, and we can continue to work on the data quality separate. A quick word on this chart. It is for the past year. We don't have tens of thousands of communication failures a month. But it also illustrated another thing, the bin full sensor. That's that second chart from the left. So what happens is each station has a bin where they receive the carriers, and there's a sensor in case it gets too full. And when it's reporting it's full, it won't accept new carriers, and that gums up the work. Again, it would be like being unable to get off the freeway because they closed the off-ramp. And when we looked at it, some of the deliveries were getting stuck on the carpet landing, and that was prematurely blocking the sensor. And it's something I saw happen in real time. One of the carriers landed, got stuck on the carpet. The second one behind it also came through, got stuck, blocked the sensor, all within less than a minute. So our solution was to change the carpet landing to a Teflon material so that the carriers slide down and don't get stuck. And in the first month after installing the Teflon, reports of the bin being full at that station dropped by 70%. So with over 200 stations throughout the hospital, our physical eyes can't be on all of them to see what's happening, which is why a tool like Domo is so useful because it makes problems visible so we know to address them. And as for what the future holds for Domo and Stanford, I'll turn it back to Sam Bedna.
Sure. Thank you, Sam. So yeah, even though we resolved like one of the most important use cases within Stanford related to pneumatic tube systems, I feel that we are still in our infancy stage. There is so much for us to do with Domo, and the vision with which we initially started to have an integrated portal for facilities is we still have to see it come to life. So we are discussing multiple use cases now beyond pneumatic tube system. We have a very we have many number of elevators that we maintain, and a lot of data related to that is something that people are interested in knowing. How are we maintaining it? What kind of issues are we facing, and things like that. Similarly, there are many sustainability initiatives that we are working on. That would find a great place in Domo. There are multiple departments within facilities, as I said, hospitality doing their compliance and quality and compliance programs. So there are many, many different use cases. And whenever we talk about visualizing the data within facilities, Domo is our go-to platform now. So we have so much more to do in future that we have already partnering with Domo on. As it is said that an end is only a beginning in disguise. I feel that when we launched PTube dashboard, that's how it felt like. Even though we delivered that project, it just was a beginning for us. And we look forward to continuing our journey with Domo and see our vision come to life. Thank you so much for your time today.